Okay, so this is the 2015 paper 1, sample paper, so we're going to begin. Use the diagram to list the elements of P union Q. Now P union Q means everything inside P and Q. So it means everything inside this section I just drew in here. So we're going to write it in order, so we're going to have 1, 2, 3, and we're going to have 4, 5 and 6 there. Okay, so that's everything in P union Q. Next thing we're going to be doing is Q intersection R. Q intersection R is numbers that have to be in both Q and R. Both Q and R will be this section in here, which is 5 and 6. And finally, P union Q intersection R. So what this means is that everything that's in Q intersection R, which is this here, and this union sign means also everything that's in P. So we can extend out the bracket to engulf P as well. So everything in this bubble here, okay, which is going to be 1, 2, 4, 5 and 6. Now Miriam says for all sets union is distributive over intersection. Name a set that you would use along with P union Q intersection R to show that Miriam's claim is true for the sets P, Q and R. Okay, now let me tell you what distributive means. Okay, if I had a multiplication, for example, so I'm multiplying 3 by 5 plus 2. I can do this two ways. I can say it's 3 multiplied by 7 equals 21, or I can multiply out the 3 and the 5, so I can do 3 multiplied by 5 plus 3 multiplied by 2, and once again I get 15 plus 6 equals 21. You can see the way I distributed the multiplication over the addition. So I could say that multiplication is distributive over addition. So that's what we're looking at doing here. So in the same breath, what I'm looking at doing here is saying that instead of doing P union Q intersection R, why don't I do P union Q and P union R and intersect the answer? So what I might do is P union Q intersection Q. So P union Q intersection P union R. So here's what we're going to do this time. We're going to get P union Q, which we already have the answer for down here. The answer for P union Q is already here. I'm now going to get P union R. P union R is this answer here. And what we have is for P union R is going to be 1, 2, 1, 2, 4, 5, 6, 7. Okay. And then it goes, name a set you'd use on this to show Miriam's claim is true for the sets P, Q and R in this. So what I'm basically saying is that if we're going to get the intersection of P union Q and P union R. Basically, what numbers do they have in common? Well, they have 1 and 2 in common, they have 4 in common, and they have 5 and 6 in common. And as you can see, it's the same answer as P union Q intersection R. So basically this is the function you'd use, and the answer to this is also going to be 1, 2, 4, 5 and 6. Okay, so next question, question 2. The sets U, A and B are defined as following, where U is the universal set. U is 2, 3, 4 all the way up to 30. A is multiples of 2, B is multiples of 3, and C is multiples of 5. So what I'm going to do here is we have 3 of these, or sorry, excuse me, I'll use an ellipse. So we're going to have 1, 2, and that one was wrong. So 3. And then we're going to have a big rectangle or square to engulf this whole thing. Okay, so there we are there. So let's start off with multiples of 2, 3 and 5. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. Alright, then you have 20, 22, 24, 26, 28 and 30. Now multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. And finally last one of 5, 5, 10, 15, 20, 25, 30. Now what goes into the middle of all three? Well, we can see that the number 30 is there in all three of them. So we'll put in the number 30. So this one can be A, this one can be B, and this one can be C. Now any other ones that are in all three sets, and I think we're out of luck here at the moment. So it is only 30 in the middle. Okay, so 30 is just one of them. Now we're going to do A intersection B now, so 30 is gone. So now we're going to do A intersection B. What do A and B have in common? Well, they have 6 in common. They're going to have 12 in common. And they're going to have 18 in common. And then they're going to have 24 in common as well. So there we go. Now, the next one after that then is, I'm going to be looking at one sec with this. I'm going to drag it down a bit further. Make it slightly larger. There we go. So the next one that we're going to have is A intersection C. A intersection C is, what do 5 and 2 have in common? Well, they have 10 in common. They're going to have 10 and 20, really being two of them that they have in common. So it's going to be 10 and 20. Now, next thing is what's left in A. Well, we're going to have 2, 4, 8, 14, 16, 18 is gone, 22, and 26, and 28. Now, look up B, intersection C. So B is going to have 15, just 15. So this number here, and then this one's going to be left with 3, 9, 21, and 27. And this one's going to be just simply left with 5 and 25. Now, we have our Venn diagram drawn out. Find the cardinal number of A union B union C complement. Okay. So find the cardinal number of everything outside A union B union C. So are all the numbers from 2 to 30 in there? Well, we have 2. We have 3, we have 4, we have 5, we have 6. We don't have 7. 7 is not there. 8 is there, 9 is there, 10 is there, 11 is not there. 12 is there, 13 isn't there, 14 is there, 15 is there, 16 is there, 17 is not there, 18 is there, 19 is not there, 20 is there, 21 is there, 22 is there, 23 is not there, 24, 25, 26, 27, 28, 29 is not there, and that's the cardinal number. So cardinal number of everything that's inside the brackets. So what's the cardinal number of everything that is in here? Okay, and then this little sign here, this comma or hyphen or whatever, that means everything that's outside it. So how many numbers do we have outside it? We have 1, 2, 3, 4, 5, 6, 7. So the cardinal number being 7. How many divisors does each of the numbers in A union B union C have? How many divisors? Okay. So how many divisors, how many things divide into 13 and 7? Well, 13 has 13 and 1. 17 has 17 and 1. They're basically prime numbers. So they have 2 divisors, because they only have the number itself and the number 1. What is the name given to that numbers that have that exact many divisors, prime numbers? Okay, move on to the next question. Okay, so the next question is question 3, and there's B and C to this question as well. So, a group of 100 students are surveyed to find out whether they drank tea, coffee or soft drinks at any time in the previous week. Here are the results. 24 had not drunk any of the 3, so 24 is on the outside. Okay, and then it goes 51 drank tea or coffee but not a soft drink. 41 drank tea. 8 drank tea and a soft drink but no coffee. Tea and a soft drink but no coffee. So that means 8 goes in here. 9 drank a soft drink and coffee. Soft drink and coffee being 9. So that's both of these added together is 9. So we just had to leave that out for a minute. Okay. 4 drank all 3. That's that one there. And it says 9 drank a soft drink and coffee. So this means that this area here has to add up to 9. That will make that one 5. Okay. And we've used that one already. And now we're on 20 drank at least 2 of the 3. So 20 drank at least 2 of the 3. 2 of the 3 is this area here. And this area here has to add up to 20. So we're going to get 20 minus 8 minus 4 minus 5. And what we're going to get is 3. So that puts that there as 3. Okay. So we'll just quickly take away that. And we put in 3 here. Now we've done that part there. We now have 24 had not drank any of the 3. We've used that part there already. So 51 drank tea or coffee but not a soft drink. And then 41 drank tea. So we can get 41, take away 8, 4 and 3. 8, 4 and 3. So what do we have there? 41 take away 8, take away 4, take away 3. 41 minus 15 gets us 26. Now we're told that 51 drank tea or coffee but not a soft drink. So this area in here has to add up to 51. So it's going to be 51 take away 3 take away 26, and that gets us 22. Okay, so that there is 22. And then finally we're missing one letter left, and this is the letter we're missing. And remember, it's 100 students in total, so we're going to add up all the other numbers and take them away from 100. So we're going to have 26 plus 3 plus 22 plus 8 plus 4 plus 5 plus 24. We're going to get 30, then we're going to get 59. 59 plus 8 is 60. I say 59 plus 4, 63 plus 5, 68. 68 plus 24 gets me 2 go to 1. What's that going to be? 82. Oh, 92. So 92 from 100 leaves 8. So this number here is going to be 8. Now, question A, represent information on the Venn diagram. Done. Find the probability that a student chosen at random from the group had drunk tea or coffee. Tea or coffee. Had drunk tea or coffee. Well, tea or coffee is everything in here. You either drank one or the other. So it's going to be 100 people, take away 8, take away 24. That equals 68, and 68 out of 100. 68 out of 100 is I think it's divisible by 4. So 68 divided by 100. Let's have a quick look. 0.68 or 17 over 25. So 17 over 25. Find the probability that a student chosen at random from the group had drunk tea or coffee but not a soft drink. Tea or coffee but not a soft drink. So what we have to do is we're not allowed the soft drink area, so we're going to get rid of anything that's in D. So this is this area in here. And what we have is 29 plus 22. Find the probability that a student chosen at random from the group had drunk tea and coffee but not a soft drink. So he has to drink both tea and coffee and not the soft drink. So tea and coffee and not the soft drink would be this part here, because you're not allowed the soft drink. So it's going to be 3 and 100 or 0.03. Okay, question 4. Dermot has €5,000 and would like to invest it for 2 years. A special savings account is offering a rate of 3% for the first year and a higher rate for the second year. If the money retained in the account, tax of 41% will be deducted each year from the interest earned. How much investment will be worth at the end of year 1 after tax is deducted? So you get your €5,000 and you multiply it by an extra 3%. So to multiply by 103%, which is what you're looking at down here, you multiply by 1.03. Okay, so 1.03, and what you get there you get 5,150. Now we've made €150 extra, so this €150 we got to take away 41% of it. So this is 100% of our interest earned, so we're going to get 41% of 150, so it's going to be 150 multiplied by 41 over 100, and then we're going to take it away. $61.5, take that away from 150. $88.5. Okay, so that's 61.5. Take it away from 150, and you get €88.50. So what we have is €5,000, and we're allowed to keep €88.50, and that makes €5,088.50. Derek calculates that after tax has been deducted, his investment will be worth this much at the end of the second year. Calculate the rate of interest for the second year, give your answer as a percentage. So what happened was, at the start of year 1 we have this much money. We then get interest added on, so we have the end before tax, and we have a certain number in here that we don't know. Okay, then we have after tax. After tax we get 5,203.60. So what we can get is the interest made after tax. Okay, so what we can say is interest made after tax. So I'm going to take this number here away from this number here to get the interest after tax. So 5088, sorry, the other way around. 5223.6 take away 5088.5, and what we get is 131.5. Now this 131.10 is the interest made after tax. Now the problem is we took away 41%, because 41% is the tax amount. So this, therefore, 100% of your interest and 41% was taken away from it. This number here accounts for 59% of our interest. So we have to find out what 100% of our interest was. So we're going to divide this number by 59, So we're going to divide it by 59 to find out what 1% is, and then multiply by 100 to find out what 100% is. So 135.10, we're going to divide that by 59, and what we get there is 2.29. Going to multiply that by 100, and what we get is 228.98. So 228.98 is the amount of interest we made this year. Now, this means so we're going to use this formula here, 1 plus I times T. Our final amount at the end of the year, before all this tax happened, was this number here, the 5088.5. We're going to multiply, we're going to add on the 228.98. So our final amount at the end of the year should have been this, but we got deducted tax. So that's 5,317.48. We start off the year, which is the P amount, with 5088.5. This 1 plus I represents your interest. I is your interest in decimal form. So if, for example, it was 5%, it would be 0.05. So we're going to say 1 plus I, and we only did this for 1 year, to the power of 1. And the power of 1 doesn't matter. Okay. Next, we're going to divide this number here by this number here, because we want to get the 1 plus I on its own. So what we get is 5317.48 divided by 5088.5. And we get is 10449, or 1045. 1.045 equals 1 plus I. Bring over the 1 and take it away from 1.05, and we get 0.045 equals I. That means that I equaled 4.5%, because remember, that's in decimal form. Okay. Alright guys, so we're on to question 5. The meal in the restaurant cost Jerry €30.52. The price included VAT at 9%. Jerry wants to know the price of the meal before the VAT was included. He calculated 9% of 30.52 and subtracted from the cost of the meal. Explain why Jerry will not get the correct answer using this method. Okay, when you include VAT at 109%, what we say is that the VAT is added on. So your meal costs 100%, and then add VAT plus VAT of 9%, and that gives you 109%. And 109% equals your 30.52. We want to find out what 100% was. So 100% of this is going to be 30.52 divided by 109. And that gets me 1%. When I divide by 109, that gets me 1%. And now we've got to multiply by 100. And we get there is €28. Now the problem with Jerry was that he got 9%. Jerry got 9% of 109%, which is wrong. Okay. So 9% of 109%. So if we got 109 and got 9% of that, he got basically 9.81% of the entire meal. So he calculated 9.81% instead of 9. So, suppose that the rate of fat was 13.5% instead of 9%. How much would Jerry have paid for the meal in that case? Well, the meal cost 28 euro, which is 100%. If we add on 13.5, we want to find out what 113.5% is. So I'm going to divide by 100 to find what 1% is. So 28 divided by 100. Then I'm going to multiply that by 113.5 to find out what 113.5% is. And I'd say €31.78. Okay.